Hello everyone, I am Anurag Jain. I am a developer advocate with Thales Group. In this video today, we are going to look into a concept of encryption, which is part of our Data Protection 101 series. And encryption is one of the most common ways or techniques through which data is protected throughout the industry. But whenever we hear the term encryption, it doesn't sound easy. It sounds like a very complicated concept, and that is the idea of this video today and following videos that will come up to make this thing easy to understand and easy to implement. In fact, as a concept, encryption is not really that complicated. And I'm going to start with one of the earliest ways of encrypting data, that is Caesar cipher. Caesar cipher is something which was invented at a time when there was no computers, there were no mathematically strong machines to achieve some of the complex algorithms. And at that point, this algorithm was discovered where if someone has to send an important or critical information or sensitive information to a third party, he can scramble that data in a way that it's not easy to understand or it's not easy to unscramble or decipher, right? So Caesar cipher leveraged a very simple mathematical operation where a key was added to the ASCII character within the plain text, and the resulting output is the encrypted value or the converted value. So in this particular example, as you can see, the key is 19 and it can be any random key. So this key 19 is added to every character to achieve the output. So A becomes T, right? And this is the complete chart, like what character will become what character. So as an example, if I have a plain text which is plain, so I can see that the character P is converted to I, character L converts to E, A to T, I to B, and finally N to G. So plain becomes IETBG. So assume the third party or the person you are trying to correspond to receive this text, and unless and until he knows that the mathematical operation that you have applied is addition and the key that is being used is 19, he will not be able to decipher that thing back. So that's the basic idea behind encryption, where we use some sort of a mathematical algorithm along with a key on the initial plain text data to achieve the intended value, so that only the right recipient with the knowledge of that particular mathematical algorithm and the key will be able to reverse it, right? So this achieves the basic of encryption, that only the intended party is able to decipher the data and not everyone else can do that. That sounds easy, right? And in a nutshell, this is encryption, where you simply use the mathematical operation using a key on the plain text data to get the scrambled value that can be understood only by the intended recipient. So, what's wrong with that? The only problem is the algorithm is very easy to crack. And as I said earlier, this algorithm was devised at a point where mathematically uh, intelligent or strong machines were not available, and hence this algorithm was okay at that point of time. But with the advent of advanced technologies like post quantum or AI and ML, and the current day computers, if you want to crack if someone wants to crack this algorithm, it's not very hard. You can use some brute force mechanisms. With some hit and tries, you will be able to get back the information that okay, this is the algorithm, this is the key, and someone can decipher that. So we really need to consider the kind of algorithm that we are using or the keys that we are using. They should not be that easy to crack. And in fact, there are organizations like NIST who are continuously evaluating older algorithms and devising new algorithms that can be used to ensure that the data remains secure. Also, we need to make sure that the key that we are using is consistently rotated. We cannot keep one single key for every operation, because that would mean that once the key is broken or key is hacked by someone, he can basically get hold of everything, right? So we occasionally need to rotate the keys and occasionally need to rotate the algorithms itself. And we also need to make sure that the key that we are using is stored properly. It's not easily accessible to everyone, because that is basically, it's the thing which is unique to your crypto operation. Okay, so before we look into more use cases of encryption and cryptography, let's quickly go through the main purpose of the cryptography itself. So these are some of the major reasons why cryptography is required. So the first one is confidentiality. As I said earlier, the data which has been scrambled or encrypted can only be read or reversed by the intended party. That is the key to the key purpose of cryptography, right? Second thing is integrity. We need to make sure that the encrypted information, wherever it is stored or passed, it cannot be modified, and if someone modifies that, original data cannot be recovered back, right? So in our previous example, if we see, if someone is using ietbg as the receive string, and someone modifies g to something else, right? So he cannot get back the original information. Third thing is non-repudiation. It is a combination of integrity and authentication, where the sender cannot, he cannot deny that he sent the information. So through cryptography, through algorithms like hashing, signature, which we will be discussing later, so someone can make sure that the information that has been received is or has been sent by a particular sender. Again, authentication is, in the same line, where the identity of sender and receiver can be established, and the origin and destination of the information can also be confirmed. And finally, the key management, which we discussed earlier, like rotating the keys, making sure the key length and the algorithms are strong enough, redistribution and generation of the keys are kept secure. Okay, so some of the use cases of encryption or cryptography in general are these. So first one is data at rest. So this is where the data which has been stored in storage systems like database, file systems, cloud-based storages like S3. So if we are storing sensitive information like credit card numbers, passwords, social security numbers in such data storages, so cryptography can be used to secure or encrypt or protect the data which is at rest. Second is data in transit. So data is still moving between different layers. You have a REST API, you have a front end. Front end is sending information back to the API. API is sending that information back to the database. At every point, or between these channels, we need to make sure that the data which is being flown, or data which is flowing in these channels, is secure. And TLS is one good example, where you, if you are hosting a website, you buy an SSL certificate, you put that certificate on your web application, and that certificate will make sure that the tunnel where the data is going between different layers is secured. And another use case is, of course, digital signature. We talked about this in some of the main purposes of cryptography: non-repudiation or authentication. So suppose you are using some documents. You are sending your college degree, or you are using some bank papers. So you need to make sure that you sign the document digitally in a way that it can be verified or it can be authenticated at the other end, so that if, as a receiving party, I can be sure that, okay, if my bank has sent me a document, I can actually authenticate that, okay, this document was sent by XYZ bank. Okay, so this is it for this particular video. We have just covered the basic concepts of encryption, like what encryption is and why is it useful. We will be covering in details like what are the different type of encryption, encryption itself, like asymmetric versus symmetric, block versus stream, and format preserving encryption. So we will understand what type of encryption to use where in what use case. We will be looking into encryption algorithms. There are some standards like RSA, ECC, DES. Don't worry about all these terms. We will be going through, these algorithms in detail in their separate videos going ahead. We will be understanding some encryption tool types, like we talked about digital certificates. We have use cases where our email need to be secured, or the full disk itself need to be encrypted. and we will see how to choose an encryption type or algorithm in which use case. So we will be covering in details like different use cases against different encryption technologies and how we can achieve that through different tools. Thank you so much for listening to this video today and stay tuned. If you like the content, please subscribe to the channel. Please turn on the notification and please share the content with anyone who you feel is looking for such concepts. Thank you so much for listening to it.